Looks like we're up and running. Boom. Alright. I guess we can start now. There we go. Now I see myself. What is up, guys? It is Zach Plochet, and in this video, this is one, my first live. Two, because there were quite a few people. Well, basically, like, almost exactly 3 people. Maybe 4. I don't remember. But some people on my cursor video felt like I was trolling them about how to build Python TicTacToe in 2025, when really I was actually showing them that you should be building things in cursor. But in this video, because of people are actually wanting the tutorial, I'm going to make it without cursor. So I went into my cursor settings, turned off the auto tab. We're not going to be using the chat this time. And with that said, let's dive in. So this is the video for today. All right, so what we're going to do here, one moment. What we're going to do here is the following. First, we're going to create our project, call it Python TicTacToe, like so. You should already have Python in your computer, of course, for this to work. Next. So I'm going to close the chat here, and I am technically still using cursor, but I'm not using the AI part of cursor. So we're going to call this TicTacToe.py. And let's actually talk about the game first. So typically, if I'm starting a project from scratch, there is a build process that starts with requirements. So this is the requirements for TicTacToe, like so. So that is the requirements. Now we're going to list them. What do we want here? So let's add some specific features. So one, basic TicTacToe functionality. Wrong answer loop. 3, usernames. Or, well, we can add usernames, but that can be a later feature. And then I guess that's pretty much it. And then play again question. So that is the conditions for our game, and of course be played in terminal. I'll put that as 0. So just the basic. That's what the requirements are. And now let's actually go into the building of it. So first, if you want to build a script or pretty much anything in Python or in software or coding in general, you want to know the general variables that exist and the general concepts. So what do I mean by that? In TicTacToe, there are some things we know about the game. The first thing that you ever do, even if you play TicTacToe on a piece of paper, is draw the board. So what does our board look like? Our board could look like this. We have some values here, separated by maybe pipes, at least initially. So that can be like that. How to do let's see. So what can we put in the middle? Let me think. How can we draw it? Like, I can think of a way of doing it without necessarily that way, or we can just only use pipes and have it like that for now. I think there is a way to do it the other way, but I just don't know it off the top of my head, so we'll have to do it this way. Basically, it'll look like a number pad. Bloop, 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 bloop. So we have a board, and we typically always have 2 symbols. So our symbols are going to be like this. This is going to be a tuple of X and Y, which we can, or sorry, not X and Y, X and O, like so. Oop. X and O, there we go. So we have our board, and basically there's 2 players. So players equal, just for now, because there's not really a great concept of what a player is. So player 1, player 2. Right. So we have 2 players, symbols, and a board. Now, since we already have these, we also know that on the board there are basically 9 positions that we want. So, board positions, and we want the user to have a human version. So this should look like the following. Instead of having like this, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Like a number pad. So this is what the board looks like kind of in general. At least initially. And then we have the board positions, which here I'll just do a short little thing. So we can say, what is it? List, let's say range of 1 through 10. So that will give us 1 through 9. Let's double check that because I'm pretty sure that's right. But print, or actually if I just say list range 1, 10. Yep, 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. So that's the positions. So we have 10 board positions and we have a board. Now, the first thing, or the first step here, step 1, introduction to the game. So, what do we put? Welcome to TicTacToe. Step 1 is just you greet people to the game. Welcome to TicTacToe. Here, actually, you know what? Can always write it this way. Bleep. Do that. Put that to the back here. Give that a little /. Triple quote that at the end. Oh wait, \. I meant. Bleep. There's a \/ there. Nice. All right. So, welcome to TicTacToe. First player has X. So, that's the game. Let's go ahead and run this and see if it works. We're going to say python tictactoe.py. See if it runs. Welcome to TicTacToe. First player has X. Or actually, you know what? We can make a player choose their symbol. Or, you know what? Never mind. Just for the sake of the game going, we can keep it this way. So, now let's have player 1 put in their turn, or their choice. So, turn 1 choice. Which also introduces a new concept, so there is a turn now. Player 1 takes their turn. So, to do that, input player 1 choose a symbol. Now, of course, we also need to actually display the board, so we're going to print the board. Or sorry, not choose a symbol. Choose a position. 1 through 9. Okay, so let's try this. Right, so that pretty much worked. Let's close a few loose ends here. Right. Actually, I like the space at the end, so we'll keep it like that. Boom. Okay. Let's try that again. Boom. Welcome to TicTacToe. Make that a bit more like this. Alrighty. Alright, welcome to TicTacToe. First player has X. Player 1, choose a position. Great. So they're going to make their choice, and then we need to actually update that on the board. So maybe instead of the board actually being a string, which would be pretty much a challenge to replace, we can actually make the well, actually, we do have board positions right here. So we just need a way of printing these board positions. So instead of what we have up here, we're actually going to build a function. So this board positions is actually the same thing as the board. At least... You know what? Never mind. So the board is actually itself going to be its own list, and then positions is just going to be positions. So that's not going to get changed, but this will be basically the same thing. Range 10. There is another way of writing this where we can use copy, but we're not going to do that for now. So board positions. Actually, you know what? We can. So board positions, copy. Copy board positions dot copy, like that. And if we print board here, or actually down there, we will see it still. So let's run this. And now we can see the board as a list of numbers. But of course we want to actually display that. So instead of it being a list of numbers like this, we want it to be somewhat organized. So what we can do is the following. We're going to make a for loop for actually, we can do it like this. Print well, okay, I think the easier way would be to do it like this. So we will say, let's see, what's the separator? 1, 2, 3, right. Gonna try to keep it from being too Pythonic, just so you guys can understand what I'm doing. Board 2, 3, like that, and then we're just gonna change these values. So 4, or sorry, 3, 4, 5. And the last one's 6, 7, 8. And that should still print the board. The only thing here is that it's not going to print the pipes, which is my main issue with it. So sep equals space pipe on all of them. Like that. Do that again. And let's try it. Right. And then print an empty line at the bottom. So that's our board. That is how it ended up being printed. If you want to see a slightly shorter way that we can write this, we can do the following. So we could say board up to 2, I think. Wait, up to 2 or 3? Might be 3. With a star. Oh no, sorry, star goes on the front. So this is just Python unpacking syntax. Be able to do it like that. Yep, I meant 3. Do the same thing here. Like this, so starboard. 3 through 6, or 3 until 6, so right before 6, and then here the same thing. Starboard 6 through 9. Then hypothetically, that should work. Right. So, of course, like, you could clean it up even more with like a loop or something, but we're just gonna keep it like that for now. I don't want it to be super duper complicated. So that's 3 ways of doing it. Now, we need to do the same thing for player 2. Oh, also, when player 1 makes a choice, we need to update the board. So whatever position they choose, 1 through 9, which is what gets showed here, we need to update that on the board. So update board with X position. So that can be like this. Board position integer for turn 1 choice. plus 1 equals X. Which is really the player 1 symbol. So we can do this now. Let's do it like this. So welcome to TicTacToe. First player has X. Player 1 choose a position. We're going to pick position 5. All right, now we didn't print the board after, so let's do that. Bloop. Okay, we got this going. Bloop. Try it again. We're going to say position 5. And it's currently wrong, so integer for... No, I should have done -1. That's what it is. -1. There we go. Let's do that. Pick a position. You know what? We're just going to say 1. All right, yeah, so that finally worked. So we got that going to position 1 now. Great. Now, you might have noticed we have some duplication. So what do you do when you have duplication? You remove it. So we want to keep our code dry, as in do not repeat. So what do? We say define display board. And in this function, we're just going to copy this, or actually just tab this over, bring that into function. And now whenever we want to display the board, we say display board. So display board again. Bam. Okie dokie. Show updated board. Run our code, make sure it still works. 1. And it does. It might be worth it to have another empty space right after it though. So print there. Okay. Boom. 1. Great. So that's the first part. Now we need to take the second turn. So 5, take second turn. So that's going to be player 2. So turn 2 choice equals input player 2. Also, yeah, instead of player writing out 1, player 1 choose a position, player 2 choose a position. 1 through 9. Of course, you know, there's slightly less available there, but let's do this now. So we take that, we're going to do the exact same thing. So we're going to print right after and then update the board with the O position. We're going to set that to O. And let's see, update board with X position. And now it's turn 2. Display the board again. So first player has X. Let's do position 5. And player 2 gets position 9. All right, so we successfully did each player's turn so far. Now, from here, we actually need to keep doing that, and we can actually add quite a few more things. Also, there's a little bit of duplication going on, so we need to clean that up a bit, don't we? So we have this repeating logic right here, where it displays the board. The player takes the turn, and it sets it on the board. And then it displays it again. So technically displaying it again, that just happens because the person whose turn it is needs to actually see it. So to do that, we're going to put this into a function now. Define take turn. This takes in a player, which I haven't decided what that will be yet, and their symbol. That is a string. Player can also be a string. So take turn. We're going to say player choice. Bring this up here. Also display board first, like so. So display board, and then turn one choice. We're just going to say player choice. Yeah, that'll be a string. We're going to replace this, call this player. Make this an F string. And next, we're going to set this on the board. Player choice. Display board 2. Player takes their turn. And then 3, update the board with X position. So, and that's basically the whole process. So if we want to simplify this code even further now, and you can see our code is still nice and clean, we could say take turn, player, player 1, and, or actually, let's go up here, players. Or, you know what, let's write it. Player 1, and their symbol will be X. Player 2 will be O. Now let's try this just to make sure this logic still works. First player has X. Choose a position, player 1. Let's do 5 and 1. Okay, yeah, it would be nice to actually see it there, but essentially it just does that at the start of turn anyways. So here's what we do now. Right, so we take the turns. So we need an actual win condition for this game. Now this part, it actually gets a bit tricky. And there's also like some validation we can do, but let's just try to make a working game first. So to do this, basically, we need to define the win conditions. So right now, define win conditions. So what are the win conditions? Define, validate, or determine if winner. Or maybe we call it is winner. We can make it a flag. What do we call this? Game completed. Right, so we can make it game completed. Give a board here. So in this case, the board is actually going to be checked. Let's see, so game completed. You take in the board. Display board. Also, here we can probably also pass this in now that I think about it. But yeah, so this is a list of, well, it's just a list for now. So, list of int or string. Lint and or string. So, and this will return a Boolean. So, or, you know what? Is winner. Right. Winner exists. Determine winner. Something like that. Determine win. Okay. Boom. All right. Yeah. So we're still live. Great. So we take in the board. The board's here. Actually, you know what? Technically, we don't even need that here. So let's do it this way. So determine win. We have the board already. And now we need to determine if there's a win condition. So what are the win conditions? There has to be 3 in a row in a certain number of ways. So there's all the way across on each column. There's vertically on each column. Or there's two ways down the middle. So that would be position 3, 4, and 7, or in coding, that's technically 2, 4, and 6. And the other way around of 0, 4, and 8. So let's do that. Let's see. So we need a way to check that all of the symbols are the same. So let's see. Row match for I. You know what? We're just going to do this the long manual way at first. So how do we do that? We say check if you know what? That's actually worth a Google. So let's Google this. It's just not coming to me off the top of my head. Check if game, or check if all what is it? Check if all values in a list are the same. Like, I'm pretty sure, like, all equal. Use iter tools. I could have swore there's like an easier version of this though. Yeah. Right. So, right, list count. Yeah, that makes more sense to me. So you count how many times that value is there. Great. Yeah, that actually works. So let's do that way. Determine when. So we can say board row 1 when equals board and then board dot 0 to 3 dot count x is equal to the length of that. Here, wait. Let's do it this way. Row 1 equals board 0 to 3. Row 2 4 to 6. Or sorry, 3 to 6. And 6 to 9. So that's the first thing. And then basically we can do the same thing with columns here. And there is probably an efficient loop way of doing this, but this is the best way I have initially. Call 3, so that's actually what? Position, boom. With 2 steps. Board equals, what is it? List range 10. 1 like that. And then say board basically from 0, but count up 2. Count up 3. Yep, that's the one. Okay, great. 0 up 3, and then 1 up 3, and 2 up 3. That should give us the results we're looking for. So like that, like that, like that. Great. And yeah, that could have actually been done in a loop. But that one would have been a little bit more challenging to actually do in a loop. So yeah, we'll keep it like this for now, even though it's not super duper tidy. So we have all the rows there. So what's the logic? If row 1 count x equals the length of row 1, or actually, like, it has to equal 3 no matter what, so match number equals 3. Of course, we could name these better. Match number is 3, like that. Let's see. Or like, bam. Row 1. Yeah, so basically the same thing, but backwards. Len match number. Yeah, it's not the prettiest solution, but I mean, it's basically what we got for now. So this part we could probably loop. So let's see. Oh, also, we'll call it diag 1 equals board. So this one, yeah, like, I don't really know another way of doing it. So board 0, and then board 4. Wait. I think I did something wrong here. 1, 4, and 7. Oh, yeah, no, that's actually the right numbers. Yeah, never mind. Okay, yeah. So, board 4, because 4 is 5, and then board 9, or 8, because that is position 9. So, diagonal 1, diagonal 2. And then, basically, for all of these, we need to check that exact thing. So, for match in, I mean, basically all of those, so row 1, row 2. There's got to be a better way. Row 3, call 1, call 2, call 3, diag 1, diag 2. Right. We're just gonna call this for row because that's just the, like, we could call it trifecta, we could call it whatever. So for row, in all of those, we need to check for symbol in symbols. And actually, for anyone who doesn't know, all caps is the syntax for defining a constant. So in our case, symbols is actually like so. And this one could be a type of, well, string, I think, symbols. I don't know if we could actually do that. Either way, it's a string. So there. Yeah, so this just makes it to where you should know that these values don't actually change anywhere. So that's just a slightly better way of doing it. So for symbol and symbols, we're going to say if row dot count symbol is equal to the length of the row. If that is ever true in any of these scenarios, we will return true. Winner exists. There we go. Yeah, I think that's the proper, that's a good name for it. So, return true. And let's see, for row, blah, 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 blah. For symbol, it's symbols. And then otherwise, it's just going to return false no matter what. So, if there are no matches, return false. Now, let's put this in a loop and see if that actually works. I'm just going to say while true, or let's see, winner equals false, while not winner. I think this will work. We're going to say, let's see. For great, so player equals 1. Player equals 2. That will go at the end. Else player equals 1. Right, so that will go at the end. Determine which player is active. So it starts with player 1, and then we're going to say the following. So take turn. And then, you know what? Players can actually go under symbols here. So what if instead we actually made these more more organized? So players will actually be a list of tuples. So on the left it's going to be the player name, on the right it's going to be the symbol. Like that. Right. Like that. Bam. Alright, yeah, so now there's 2 players. And they each have their own symbol. So, how about this? For player in players, that player takes a turn. Player, or actually, let's do this. Player name, player symbol. Now we don't need that variable up there anymore. That was just showing which player it was. So for player and player symbol, for player, symbol, and players. There we go. Now we're unpacking 2 at a time, having access to them both. So symbol like so. Take a turn, and then determine winner. Right. Or sorry. If winner exists, break. Yeah, so that's another way to do it. So let's just simplify this part. While true, that just keeps the loop on forever. So for symbol in players, take turn, player, and then the symbol. If a winner exists, break it, and then say, I guess whoever's turn it was, winner equals none. If winner exists. Then we set the winner and say player, whoever that player was. And also display board one more time. Right, and I do believe that's actually the game. So we just say what? I guess here we can write it. Player 1 wins. Or player, whoever the player is. CT1 winner wins. Bam! And hypothetically, that should be the whole game. So, let's see if this works. Exit pie TicTacToe.py. First player has X. Of course, player 1 choose a position. We're going to pick 1. Player 2 can get 5. Wait, okay, something is wrong there. Oh, I'm not using symbol. Right. So, we switch this with whatever the symbol is. Boom. Let's try this again. 1, 5, 2, 6, and 3. Player 1 wins. Oh, wait, and it's still going for some reason. Oh, right, so that broke the for loop, and then, yeah, how can we break? Ah. Player and player. So if a winner exists here, break. And then we need to break again, if there is a winner. Right, so winner equals player, and then print that player. Yeah, and that should hypothetically do it. So, first player has X. Oh my god, I just realized that you guys can't actually see the card output. Hold up. That is really embarrassing. Oh well. It's first live. What can I do? Alright, I'll put myself up here. There we go. Get that chat out of the way. And I guess we'll keep going. So, let's try this. So, 1, 5, 2, 6, 3. Player 1 wins. Alright, great. And that is true. So, that's how you build the initial version. Now, if we want it to have here, wait, let's look at the requirements just to make sure we did everything. So, be played at terminal, that's done. Basic tic-tac-toe, wrong answer loop. So what happens if I put, if we do this and I say F? Boom. All right, so that's an issue because there's no integer value for F, and yeah, you didn't put it in a position. So how do we check that? We need to validate each answer. So there's actually a 2.5, validate each answer to make sure it's real. If player choice not in board positions, which is up here, we're going to say player, or actually, we're just going to print invalid answer. Right, so if we do this, I'll show you what happens because this is not a complete solution. So if we do this, I say print, I'm going to put 10. Right, so 1, that broke there, and then also 2, all it did was print invalid answer. So we actually need to fix that. In order to do that, we're going to make the person take a turn again. So what we'll do instead is we're going to say while true. So the same infinite loop here. So basically, if player choice not in board positions, print invalid answer. else break. And then we can continue. So that's a very simple way of continuing a dialogue until that is resolved. So also we're going to end this with a new line. That is how you do it. This is an alternative to just writing print at the end, by the way, or adding an empty print just for a new line. So that's what that is. Let's try it. So we're going to say 1 or 10. Invalid answer. Great. Now we can continue. Nope. Okay, so that's not quite right. So we did do, oh, because, right. If the integer version, well, okay, so that actually there's a few things. So we're gonna say 2.1, make sure value is an integer, and that will raise one error. So if, or we're gonna say try int player choice except print, we're going to say choice must be an integer between 1 through 9, or choice must be a number. Right, so that is the first sort of situation that we need to check for. 2, so this is 2.2. Then we need to check if it is here. So if player choice, since here, if it works, it's just going to work. Also, I don't know that base exception is the exception there, so we're just going to try it until something else happens. And then here we're just going to say continue. Continue just sends it back up to the loop if the code reaches here. So that's what that happens. So it goes continue and then starts at the top instead of keeping going. So 2.2 is here. If player choice is not in board positions, print invalid answer. Whoops, close that in cursor. If player choice is not in board positions, yeah. So that, I think that's basically true. So let's try that. Let's do 1. Oh wait, yeah, so that actually worked. Hold on. Let's do 10, or let's do F. Choice must be a whole number between 1 through 9. Yep. Add the little extra spacing there just for being happy. Right. Let's do that. Okay, so let's try that again. F. Choice must be a whole number between 1 through 9. Let's do 10. Invalid answer. We didn't say why, but like essentially you would give a better error message there. Invalid answer. Number must be between 1 through 9. Okay. Let's try that again. 10. Invalid answer. Right. Okay. And what about... Well, I guess that's pretty much it. But what if we did this? I'm going to put 1 here, and then I'm going to put 1 again for O. Right. So all I did was just replace the first value. So we don't want that happening. So to fix that, we're also going to say... in this loop, might as well, we're going to say current board current value so we're going to say position value equals board integer player choice minus 1. And then we're going to say if type. Yeah, so how do we do this? Actually, we can just say this. If position value in symbols we're going to say print invalid answer. That position was already chosen. Pick another position. You can make it more human, be like, whoops, that spot's taken. Yeah, there's lots of things you can do there. So, and then we will continue from here. And then if all actually works, we will go all the way to the bottom and end it. Boom. Else. Oh wait, no, sorry. Actually, there is no else. Right. So let's do this. We're gonna say F. That didn't work. Let's try 10. That didn't work. I'm gonna pick 1. Oop. What happened? Position value list is not a callable. What did I do? Oh, right. Bam. Oh, also, that's already an integer at this point, so we can remove that. .3, ensure the position is not already taken. And now we can try again. So, tic-tac-toe. Let's try it. F, 10, and 1. Also, we can't see the board right here, so that's kind of a problem. Display board. We can put that right at the top here. And basically, this whole thing just turns into a big loop. Right. So, let's see this. First player has X. Player 1, choose a position. Let's do 1 and try 1 again. Invalid answer. That position is already chosen. Pick another position. Let's do 2. Nice. All right. So, now that's like that. Also, I just realized we don't actually have tie logic. So, if all of those items are strings, then that means that we failed. So, let's try it. So 3, 4, 5, 6, 7, 8, 9. Oh, nope. Actually, I lied. So in that case, you would still win. But if we made it better, so let's say 1. And then let's do 1. I'll do 2. Now we'll do 8. I'll do 3. Now I'll do 7. Now we'll do 4. Now we'll do 6. And now I'll do 9. And what happens? Right, so we can still keep going, which, of course, there's no more places to take. So another thing we could do is check for a tie. Check for tie. This returns a Boolean as well. Let's see. So, how do we do this? We basically just say return all position in board, or for position in board. So all is a function that just checks if everything inside of this is true. Yeah. So all it checks if every single item inside an iterable is true, then it returns true. If not, it returns false. And yep, that's basically the gist of it. So hi hypothetically, that should work if winner exists or tie exists. Yep. If winner exists or tie exists, break, and then if it's a winner, display the board and do that. Elif tie exists. Still want to display the board. In this case, like, there is a little bit of duplication, but it's slightly different. So we're just going to say it's a tie. Like so. And then we break again. So, yeah, that's pretty much the best way I could think about going there. Cool. So, that's that. Let's try it. See if that works all the way up to that point. So, what is it? 5, 1, 2, 8, 4, 6, 7, 3, 9. It's a tie. All right, cool. So that actually, the whole thing worked. Now, what do we do if we want to play again? So to do that, how do we do that? Right, so basically all of the parts up to here is only for one time. So we do create the board up here. Let's see. I know what to do. We could update the board with board positions again, because this is just a copy of what this was. So, yeah, let's do that. Get rid of match number here, and we could probably clean this up, but it does technically work. So even though it is a big ugly function, yeah. There are ways of cleaning this up, I know, just it's not coming to me at the moment for some reason. So why don't we do this? There's two loops. We have a loop inside of a loop. There's the game loop. And then there's the main loop, which is actually a thing, now that I think about it. So in here, if we get a break here, all we're going to ask is, would you like to play, or actually it's an input. Input, would you like to play again? Yes, no. We'll make no the default. So if play again is in or is equal to y play again dot lower, because maybe they have caps lock on or something, as equal to y, then, or actually it's pretty much just does not. So if it doesn't equal to y, then break. Otherwise, it just keeps going. Let's try it. So I'm just gonna try to win this. 5, 2, 6, 3. Player 1 wins. Would you like to play again? I'm just gonna press enter and it should just break. All right, let's try it again. 1, 5, 2, 6, 3. Would you like to play again? Yes. And then it played again. But is that the right board? Right, because I forgot to actually reset the board. So we're just going to say board equals board positions dot copy, like so. Try that once again. One, 5, 2, 6, 3. Yes. That should have actually updated. Unless I didn't save it, but pretty sure I did. Now, why would it do it? Okay, so we'll have to change one little bitty thing. So here, when we say display board, we're going to pass in board as an argument of a list of strings or integers. So board becomes something that we actually pass into the display board part. So this is the game loop. Actually, well, yeah, no, that makes sense. Board equals, here, wait, let me just paste it from before. Board equals that board. Take turn. If winner exists inside of that board or a tie exists inside of that board, which is now going to be the same value, board integer. Go down here, board yep, that looks good. Now that looks good. And I do believe that's all the places now. Yep. Looks right to me. Let's try it. 1, 2, whoops. Wait. Positional argument. Oh. Right, so that's here. Board. Yeah, so not the most convenient anymore because you have to pass it in every single time. But it does work. Otherwise, I could have swore I had that working before, but I guess for now, I don't quite remember how I did it. But I think there is a way to make that work. But for some reason, I did something here to where that's not the case. So we're just going to clear that and define the board at the start of every game. So bam. Oops. Try that once more. 1, 5, 2. Whoa, wait. Why is that not working? Because board needs to be defined up here, not out there. 1, 5, 2, 6, 3. Yes. There we go. All right. Also, let's print a new line right here. 1, 5, 2, 6, 3. Yes. Why is it not printing? Huh. So I'm gonna, oh, if it's not, oh my god, oh, it didn't work because, hold on, okay, we're gonna fix this because I just realized that if I say no, then it breaks. That was dumb. Okay, yeah, let's just undo all of that stuff because that was a mistake. Alright, so, OMG, board equals board positions.copy. We can actually put that at the bottom because if they do want to play again, they can continue. So if play again.lower does not equal y, stop the game. And if it does, then reset the board. There we go. That's slightly simpler logic. 1, 5, 2, 3, 6. Actually, I screwed myself there. Hold on. Bloop. 1, 5, 2, 6, 3. Would I like to play again? Yes, I would. Alright, I didn't fix the other part, but as you can see, the board is resetting and we didn't have to add that variable everywhere once again. So, I do believe that actually hits all the boxes. Usernames is the only thing I did not add, so yeah, if we want to add that, we can. But that can happen when? Yeah, I mean, I guess it can happen in the main game loop, or perhaps outside of the game loop. So this whole thing is the main loop. And we could just say user1 name. We'll actually define that up here. So players user1 name equals input user player 1. What is your name? Player 2. Like so. Bleep, bleep. Right, and then that could be used for the whole thing. Let's see. Player 1, what is your name? Zach. Player 2, what is your name? Jeff. Zach, choose a position. Great. Jeff, choose a position. Nice. 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 Zach wins. Alright, and as you can see, I just easily added usernames to this whole thing. Would you like to play again? Sure. Oh, I didn't press Y. Zach. Elon Musk. Great. 1, 5, 2, 6, 3. Zach wins. Take that, Elon Musk. All right. So usernames, play again question. Yep, that hits all the box. So I do believe that concludes it for this video. So thank you for watching. I hope you enjoyed this really long live stream. And as you can see, that took me about an hour. Could it be done a lot faster? Probably. You're not wrong. Could it be done way faster with cursor? Yes, because I made a video of me doing it in about 30 seconds to a minute. So, with that said, that's it for this stream. I hope you guys enjoyed it. It's my first YouTube stream pretty much in a while, and one that was actually more official. So, thank you so much for watching. I'm really tired. It's like 9:30 here. I'm gonna go to bed. Thank you for watching, and bye for now. Psh.